Right, so now that we looked at some of the services the system provides, I think that's a good point to start off and look at what are the main functions of an OS. So let me clarify here that the OS has numerous functions, which is why the OS is the most important part of any system. You cannot have a functioning system without an OS, and of course it is not possible to go through an exhaustive list of all functions. We will be looking at the most important functions. Resource allocation, process scheduling, these are things we will be looking at in detail. Execution of user programs, I believe, is self-explanatory. So when you write a program and when you click on run or enter or compile or execute or whatever, it is the OS which tells the computer to run it. And even when you're not writing programs, when you click on an icon, let's say I click the icon for MS Paint, how does my computer know that I have to open MS Paint? That is also in one sense a user task being executed, right? So all these tasks are executed under the guidance of the OS. Interrupt handling, we will look at it, memory management, input output, file system management, and timer. So in the upcoming segments we are going to be looking at some of these functions in a little more detail. Okay, we will start with resource allocation. So before I talk about what resource allocation is, let us understand two terms: multi-programming and multitasking. So both of these happen in the modern computers, laptops and devices we have today. So multi-programming is when a system has multiple CPUs. So one device which has multiple CPUs, and each CPU is executing one process or one task at the same time. So there is a slightly more technical definition for the word process, which we will be looking at somewhere down the line. But as of now, you can assume a process is a task, a program, an activity, one function which you want the computer to perform, or one command which needs to be executed. You can think of it as a process. Now, multi-programming says your system has multiple CPUs. So you might have heard these terms 4-core, 6-core. So each core is basically a CPU. So when I say this has an Intel 4-core processor, it means this laptop has 4 CPUs. So each of those CPUs can execute one program at a time, meaning at any given instance, you can be executing 4 programs at the same time, up to 4 programs, if it's a 4-core system. So that is what we mean by multi-programming. And the other case is multitasking, where one CPU is doing multiple tasks at the same time. Now there is a caveat in this definition. Technically, one CPU can only perform one task at one instance. So it is not multitasking in the sense of doing 2 or more things at the same time. But the CPU generally rotates between tasks at such a high speed that it almost feels like it's doing multiple tasks at the same time. So it's like at time t, it will be doing one particular task, let's say process P1. At time t plus 1, it will do P2, process P2. At time t plus 3, it will be doing process P3, and these time intervals will be in milliseconds or nanoseconds, right? So when you look at it from the perspective of a user, you will feel like within 1 minute, 5 or 6 tasks are being done parallelly by the CPU. So that is multitasking. So the main difference between multiprogramming and multitasking is multiprogramming, there are more than one CPUs. Multitasking, it is one CPU. But in both cases, a lot of programs are being executed at the same time. So what has this got to do with the OS? In either case, it is the OS which needs to allocate tasks to the CPU. So if you have 4 CPUs, it is the OS's job to say CPU 1, you do process 1, CPU 2, you will work on process 2, and so on. Or if you have one CPU and you have 10 processes waiting to be executed, it is the OS's task to say at the first instance you will work on task 1, at the second instance you will work on task 5, and so on and so forth. So it is allocating tasks, basically coordinating the transfer of data. So there might be multiple tasks which require the same data, which may have to access the same memory locations. Like going back to our WhatsApp web example, you can think of the 2 tabs as 2 independent processes. Now both of them have to access the same URL, right? So it is the OS which is coordinating between these two, helping them communicate with each other, helping them understand that they are both looking for the same URL and both of them cannot have it at the same time, which is why you get that alert pop-up saying please close one tab and use the other. So the OS is responsible for inter-process communication. This is an important concept which we will be looking at in detail when we study about processes. So that is the first function of an OS, the resource allocation and everything that is related to process execution. And by resources, I also mean computational power and CPU and memory, RAM. Basically, it can be any sort of computational resource. It is the OS job to allocate resources for a task and a task to the CPU.